Good day, hope that you're doing well. So in this video, we're going to be going to you with the question paper from the November 2023 paper 2, grade 11 maths. Now, we're going to be doing question 4. Now, question 4 is an integration of analytical geometry with some bit of Euclidean geometry, right? Now, here we are given in this diagram below, line AC and BD and BC, they intersect one another at B, right? Whereby they are perpendicular to one another. Now, they've given us the equation of AC. Now, AC is Py minus X minus 5P is equals to 0. Now, we need to determine the coordinates at C. Now remember, making use of your equation at AC, which is Py minus X minus 5P is equals to 0. You need to try and calculate the coordinates at C. Now at C, I can see that C is my y-intercept, meaning that I know in this instance that my X is going to be equals to 0. So Py minus 0 minus 5P, this is going to be equals to 0. Now I'm going to try to determine my y coordinate, right? And how would I go about doing that? So basically here, I'm going to take the 5p to the other side. So here I'm left with p multiplied to y. It will be equals to positive 5p. Now I want to make this equation to be in terms of y because I'm determining the y coordinate at c. So I'm going to divide both sides by p. And if I do so, this p is going to cancel out with this p. Same applies to this p here. It's going to cancel out with this p here at the bottom. So as a result, my y is going to be equals to 5. So the coordinates at C, they're going to be equals to 0 and 5. So the coordinates here, it's 0 and 5. Right? Now let me try and erase here so that we could answer the preceding questions. Now I'm being told that the gradient of AC is a half. Now if the gradient of AC is a half, I need to show that the value of P is equals to 2. First, I'm going to try to make this equation that I was given initially of Py is minus X minus 5P is equals to 0. I'm going to try to make it in terms of Y, right? And if I do so, right? If I do so to try to make it to be in terms of y, so basically I'm gonna put the other values to the other side. So here I'll be left with py on the other side. When I transfer this x, it's gonna be a positive x, and when I transfer this 5, it's gonna be a positive 5. And afterwards, I'm gonna divide both sides by p so that I could make this equation to be in terms of p, right? So basically doing so, dividing both sides by p. So p would be divided to my x as well as my 5p. So my y would be equals to x over p plus, now this p is going to cancel out with that. So as a result, this would be plus 5. Right? Remember, this here can be written as x over p plus 5 over p. Right? So plus 5p over p rather. Right? Hence I said this is going to be x over p. And as a result, this here is going to cancel out with that. So we're going to be left with 5. Now, simplifying this. So remember, when you have your equation as y is equals to mx plus c, your gradient is whatever value that is attached to your x, right? So here, if I were to rewrite this equation, this could be in terms of, so I could write it as 1 over p multiplied to x plus 5. Because here I would multiply numerator by numerator, which would be 1 multiplied by x, and denominator by denominator, which would be p multiplied by 1. So as a result, this would be x over p, right? Now, it means that here, my gradient in this instance is 1 over p. And they gave me the value of my gradient here, right, as 1 over 2. So I need to solve for my value of p. Right? And how would I go about doing that? Because I have one value on the left-hand side as well as one value on the right-hand side, I can cross multiply. So p to be multiplied to 1 and it would remain as p, and 2 is going to be multiplied to 1 and this is going to be 2. So as a result, my value of p is going to be equals to 2. Right? Now I've proved that. Now let me substitute 2 into the formula. Right? So basically this is my equation, which is in terms of y. And if I substitute p into that formula, that's the same as y is equals to 1 over 2 multiplied to x plus 5. This is the equation of our line AC. Now, proceeding to the next question, they want me to calculate the coordinates at B. Now, B is a point whereby your line AC as well as your line BD meet, right? Meaning that if I could equate the equation of AC with the equation of BD, right? So let me highlight the lines I'm talking about. So these are my lines, which are perpendicular to one another, right? So here, I'm saying that, okay, this point B is where these two lines meet. Meaning that if I would equate the equation of AC with the equation of BD, I'm going to find my coordinates at B, right? So I already have my equation of AC. Now, can I find the equation of BD? Remember, if these two lines are perpendicular to one another, right? So your equation must be in the form of y is equals to mx plus c. So if these two lines are perpendicular to one another, I can find the gradient at BD, right? Because why? If I take my gradient Because if I take my gradient of AC and I multiply it to the gradient of BD, I expect to get -1. Now, the gradient of AC, I was told that is equals to 1 over 2. So basically, if I take 1 over 2 multiplied to the gradient of BD, I expect to get -1. So to find my gradient of BD, I'm simply going to divide both sides by 1 over 2, right? So here, if I divide this side by 1 over 2, these two are going to cancel out. And as a result, my gradient of BD is going to be equals to -1 divided by a half, which is going to be -2, right? Now, remember, the equation should be in a form of y is equals to mx plus c, right? I have my value of m as -2, and c, remember, it's my y-intercept. My y-intercept in this instance is at -10. So this would be the equation. So here it would be -10. Now remember this gradient right over here, right? Before I forget, this here it's a negative here. So this here, it's -2x minus 10. Now let me equate the two equations together. -2x minus 10, it is equals to 1 over 2x plus 5. Now here grouping like terms together, right? So I'm going to say -2x. This coming to the other side is going to be -2x, -1 over 2x rather. There I have 5, and this is going to be positive 10. Now, -2 minus 1 over 2, this is going to be 2 comma 5, or -2 comma 5 rather, x. -2 comma 5 x is equals to 15. Now, to find my x at b, I'm going to divide both sides by -2 comma 5, so that these two could cancel out one another, right? And my x would be 15 divided by -2 comma 5, and this would be equals to -6. So my x at b is going to be -6. Now to find the corresponding y, I could just substitute this -6 into any of these two equations. I'm going to substitute it here. So the y is going to be -2, -6, -10. So as a result, this here is going to be equals to 12 minus 10, which is the same thing as 2. Now my y at b is going to be at 2. All right, and that would be how I can go about determining my coordinates at point B. Now, the next question, they want us to find the size of A. Now, if A is the angle of inclination, remember your angle of inclination formula, tan of A in this instance, it will be equals to the gradient of your line AB, right? And remember, the gradient of your line AB, right, it will be the same as the gradient of your line AC, right? Because AB and AC, they are on the straight line, or rather, they are on the same line, right? Now, here, my gradient of AC is equals to a half. So basically, tan A is equals to a half. Now, to find this A, I'm going to take the tan to the other side. My A to be the inverse of tan, a half. Now, I'll just punch this into my calculator. I'm punching this into my calculator. My angle of inclination rounding off to two decimal places, it will be equals to 26,57 degrees. Now, prove that ABOD is a cyclic quad, right? So now let me try and go about doing that, right? So first, let me try and erase here and highlight the cyclic quad that they want me to prove. Now, to highlight the shape that I did, this is A, B, a line from A to B. And my O is my origin point. This would be my other line. And these two are going to join. Now, can you see the butterfly that is formed? So basically, I found this angle here. If I could prove that this angle is equals to this angle here, therefore, this whole shape, right, ABOD is going to be a cyclic quad. So now my angle A, I know that is equals to 26,57, right? Now let me try and solve for my angle B. Now, how would I go about finding my angle B? So can you agree that here, if you look at this triangle that I'm given here, that I'm going to try and determine B, or let me try and separate it here. So here you have your B, which is at 90 degrees, and we're trying to determine this beta angle. Can you agree that if I can find C, therefore it will be easier for me to find my angle B, right? Now, how would I find C? I'm going to use this triangle right over here, which is also a right angle triangle, right? So I'm going to use this triangle because I have angle A. I know that this is 90. I can find angle C, all right? So now let me solve for C. I know that angle C is going to be equals to 180 minus 90, right? Minus my angle of inclination, which is 26,57. Why is that? Sum of angles in a triangle. And to be specific, which triangle am I referring to? I'm referring to triangle ACO, right? So here I'm going to name in triangle ACO. Now, as a result, my angle C, it's going to be equals to, my angle C is going to be equals to 63,43, right? So I know that, all right, my angle C, all right, this angle here is 63,43. Can I find B? Yes, using the same approach. So now I'm going to name my triangle in triangle that I'll be doing my workings on. So this is triangle BCD, right? Remember here is my point D. So in triangle BCD, if I take angle B and I add it to angle C and I add it to angle D, this is going to be equals to 180. And my reason would be sum of angles in a triangle. So as a result, my angle D, which is represented by beta, is going to be equals to 180 minus 90, because remember, your angle B is 90, your angle C is 63,43. And this would be equals to 26,57. Right? Now, because angle B, or your beta, therefore, because our angle of inclination is equals to our beta, therefore, ABOD is going to be a cyclic quad, right? So therefore, ABOD is a cyclic quad. All right, perfect. Now, determine the coordinates of the center of the circle which passes through DBC, right? Now, let me try and draw the imaginary circle, right, which passes through DBC. So the circle passes through the coordinates D, BC, and D, right? This is my imaginary circle. Now, I want you to know something, right? I want you to note something. So this line here, it will be a chord in this circle, right? And my line from D to C, right, it would bisect this chord. Because why? This line from D to C, it meets at 90 degrees with my chord, right? So as a result, it's gonna bisect this chord into two equal halves, right? It's just that this circle is not drawn up to scale, right? And what is this theorem? This is the converse of theorem 1. Now, I want you to note something, meaning that if we were to be able to find the center of the circle, right? How can we able to do that? So we can find the midpoint of our line DC, right? And also because this is a vertical line, it's a straight line, right? So to find the midpoint of this line DC, we're going to make use of our midpoint formula. As a result, we're going to find the coordinates at our center, right? So here, I'm going to say, okay, my x at D plus my x at C all over 2, my y at D plus my y at C all over 2. Now, what is my x at C? This is 0, right? Or rather, let me start with my x at D, which is also 0. So this is 0 plus 0 all over 2. Now, my y at D, it's minus 10 plus my y at C, which is 5. And everything would be divided by 2. So as a result, this side, I'm going to have 0. And this side, I'm going to have negative 5 over 2. And this would be the coordinates of my center. And that will be all for this question. Remember, if ever you have any questions, always feel free to reach out. Thanks.